Hey, good morning, everybody. My name's Ron. I'll be leading you through a discussion this morning about water storage tank math. This is applicable to the drinking water level, let's say level B and level A exams for the state of Florida, but would also be found on AWWA and ABC quiz questions, and is just general good information as a water operator to be able to do this math. So it's not just for test purposes, right? So I'm going to lead you through a discussion about how to solve some of these kind of more conceptual math problems. There's not directly a formula on the Florida formula sheets that we use in our exams here in the state of Florida. There's not a direct formula that shows storage tank math like what we're going to work out here, but to be honest with you, this is what they call conceptual math. Can you see these concepts? Can you figure things out using the conversion tables? And you'll need to remember some basic things about cubic feet and gallons per minute, gallons per day, and million gallon units. So you'll also need to know how to do a percentage. So if there's a certain number of gallons in a tank and the tank is only, half full, 50% full, well, half of whatever number they give you is how many gallons are in there. So 50% of that number. So you'll have to be able to do that as well. So if you're kind of rusty on some of those concepts, go back and practice some of the math that we cover in other videos that I've made. You'll find some other videos on our Vimeo site about water distribution math and water math for the state operator exam. So hopefully this will help you guys out. And I want to share a quick story with you as we go through this. So I'm going to switch over to the PowerPoint presentation and we'll kind of get into this. All right. And I want to hide this little meeting control thing because it's in my way. Getting better at using Zoom. Not 100%, but I'm getting better. Okay, so storage tank math. We're going to kind of work through some conversions and formulas to show you how to figure out gallons in a tank and things like that. So we have a copyright statement for these videos. Remember that these are copyrighted by the Center for Training, Research, and Education for Environmental Occupations, otherwise known as the TRIO Center. And this is April of 2021, kind of closing out the month of April. And hopefully you guys are doing good this year. So my name is Ron Trigar. I'm a certified environmental trainer at the University of Florida TRIO Center. My contact number is 352-294-3881. My email address is rtrygar@trio.ufl.edu. And please visit our website at uftrio.org. And don't forget also that we are on LinkedIn and on Facebook. So visit our Facebook page to kind of see what's been going on here with TRIO and all about our other classes that we do and the other programs that we have here and some of the training that's been happening this year, since we've been kind of coming back from our COVID pandemic shutdowns and all. So check us out on Facebook and LinkedIn and also visit our website. The references I want to tell you about here are specifically the DEP, Florida DEP Operator Certification Program, Drinking Water and Distribution System Math Formula Sheets. That's what I'm showing here. If y'all can see that. That's what we're using, and they're dated June of 2020. So they were updated about a year ago by the Water Committee that is part of the State of Florida Operator Certification Program Exam Review Committees. And I want to give a special attention, shout out to a buddy of mine named Dr. Charlie Martin, who helped me clarify some of this math because my brain gets a little rusty, just like everybody's does from time to time. and I had a specific brain fart on how to solve something. And I always like to run things past people, and I have my own set of contacts that I use, just like you probably do. And you contact your friend or your assistant or somebody that helps you out, somebody that you trust and up here. And Charlie is that for me. And I reached out to him about a math problem, and he clarified something for me. And so I figured I'd make this video so that way we could, kind of solidify this and make sure that that we're not going to be rusty after this, because sometimes if you don't use it, you forget it, right? So that's my statement. All right, the first thing we're going to work on is the gallons in a tank, and then figuring out if the tank is a certain percentage full, then how many gallons would be in the tank. So you see in this picture some ground storage tanks at a large water treatment facility. And we have a tank in this statement says that the ground storage tank is about 28 feet tall, has a 90-foot diameter. The tank is 75% full. So how many gallons are in the tank? So we'll go ahead and switch to the next slide so we can use the white space here to work the math. And let's go ahead and figure this out. I got my calculator. I hope you guys have your calculator handy and a cup of coffee, and you're ready to go and work these things out. Work these out with me. If you'd like to stop the video here and work it out yourself and then restart it and see if you match up the way I worked it, that's great. Also remember that there's always more than one way to do some of these math equations. I'm showing you the way that I usually do it. So use what works for you. As long as we come up with the same answer, I'm good with that. Just remember that there's usually more than one way of doing some of these conversions. And as long as we land on the same answer, then I think we're pretty good to go. All right, so first things first is we got to figure out the cubic feet volume of the ground storage tank and convert that into gallons. And remember that this is a round or cylindrical tank because the word diameter is in there. So you can use formulas similar to what I'm going to show here. Remember that there's 3.14 multiplied by radius times radius, as these are in feet units, right? And to figure volume, then it would be the height of the tank, and again in feet units. That's one method of doing it. You can also do 0.785 multiplied by diameter in feet, and diameter in feet times the height. So either formula will work, and you should come up with the same answer. I usually choose to use the 0.785 method when I'm faced with a diameter dimension in the question. So I just trained myself over years just to say, okay, I'm going to use the 0.785 because that's what's given to me. So let's go ahead and erase this, and we'll go ahead and work this out. So erase all the stuff on the slide, and let's get back to it. All right, so we've got 0.785, multiply that by the diameter twice. So it's 90 feet times 90 feet, and then multiply that by the 28-foot height. And that's going to give me cubic feet. So I'm kind of taking this step by step. So you can always work it out a little faster if you'd like, but 0.785 times 90 times 90 times 28. And I came up with cubic foot volume of 178,038. So this is cubic feet volume. Now we have to convert that into gallons. Don't forget the 7.48 gallons in a cubic foot. That's where a lot of people tend to forget, and they don't go the next step, and they keep working the math, and then they get the answer wrong. So don't forget that we have to convert this into gallons. So 178,038 cubic feet. We're going to multiply this by 7.48 gallons per cubic foot. All right, so now just multiply times 7.48, and I came up with gallons of 1,000,000 331,724.24 gallons. All right, so 1,331,724.24 gallons in this tank. Now, don't forget the tank is 75% full, so it's not completely full. So what we need now is 75% of the 1,331,724. So to figure out the percentage, we're going to convert that 75% into a decimal, which is essentially going to be 0.75 as a decimal. So now all we need to do is to multiply the value that we have here times 0.75, which represents the 75%. And remember that we should come up with a smaller number than what we're starting with, because we're only 75% full. It's not 100% full, it's 75%. So it's less than a whole 100. So we should come up with a smaller number on our calculator. If you come up with a larger number, it may be because you divided it instead of multiplied it. So don't do that. Make sure you multiply to get the right value. So we're going to multiply by 0.75. And on my calculator, I'm getting 998,793.18 gallons in this tank. Because it's 75% full. So 998,793.18 gallons are in the tank at 75% full. And there's our answer to this question. All right, let's move on to the next concept. I hope that this was helpful. If you want to try it out, make the number be something different. You know, if you want to try something for your facility, let's say you have 87-foot diameter tanks that are only 25 feet tall. Then work the math out using your tanks, you know, then try it out that way. Just follow along and see how you do. All right, let's move on to the next question. So this question is asking us that if we have a ground storage tank that contains 998,800 gallons, and we have a high service pumps that are withdrawing 1,200 gallons per minute from the tank, how many hours will it take to empty the tank? So we have essentially kind of like a detention time question in front of us here. So this question is using the same capacity of gallons that we just worked on, but now we have a pump pulling water out of the tank. So without any fluid coming in the tank, which is what we're going to talk about next, but we don't have any water coming in the tank. We just have the 1,200 gallons per minute being pulled from it. We have to figure out now how many hours will it take to empty the tank. So what we're going to do essentially is we're going to take the 998,000. Remember, you can stop the video here and try it out on your own and see how you match up to what I've got. So we've got 998,000 gallons in the tank, and we want to figure out how much time it's going to take to empty the tank. So we're pulling out at 1,200 gallons a minute. So I'm going to go ahead and put the 1,200 here, gallons per minute. Now, some people would say, well, if you want this to be in hours, you could convert the 1,200 gallons per minute to gallons per hour if you'd like, and then come up with a direct answer. Well, either way, you'd still have to do some extra math here to get it into the hour units. So I'm just going to go with the 1,200 GPM, and let's first figure out how many minutes it will take. So we got 998,800 gallons. Divide that by 1,200 gallons per minute. So I'm coming up with 832.33 minutes, okay, because gallons cancel each other out. We're left with minute units. So we've got 832.33 minutes of time, but we want this to be in hours. So we're going to take the 832.33 minutes. And now we want this to be an hour, so we're going to divide this by 60 min per hour. And we're going to get a smaller number because now we're working in hours. So 832.33, divide that by 60. And on my calculator, I've got 13 I'm going to go out to the hundredths column here. So 13.87 hours of time before that tank empties out. So you may round this, you may say 13.9 hours. You know, if you're taking an exam, they might put something more like 13.9 on there. They wouldn't, you know, obviously test writers wouldn't put 13.87 and 13.9 as separate question or answers, but if you rounded, you'd be good to go here. So essentially 13.9 hours if we're pulling out of the tank at 1,200 gallons a minute. All right, so we're working from simple to complex, or let's say easier math to the more complex math. So I'm going to keep adding stuff to this question, and it's going to get more complex as we go through. So, you know, stand by, right? What if we're filling the tank while at the same time we are withdrawing water from it? So now it's getting a little trickier, right? We actually have liquid coming into the tank, and we have water coming out of the tank, right? Going out this pipe here, and we've got water in the tank. So now we're getting even more tricky. We got to figure out how many hours would it take, or how many days of storage we have before the tanks are empty if we're flowing at certain rates. So that's what we're going to work on next. Okay, a lot more words, and we're getting more tricky here. A ground storage tank has a capacity of 4 million gallons, but it contains 3.2 million gallons. The flow into the tank from the treatment plant is 750,000 gallons per day, and the high service pumps discharge 850 gallons per minute into the distribution system. How many hours will it take to empty the storage tank? All right, so this is our next question. So we're going to work this out, and we're going to start with some of these conversions. First thing we have to do is recognize what is necessary for this question. One of the first things we notice is that it has a capacity of 4 million gallons, but it now contains 3.2 million. So we don't really actually need the 4 million gallon number. That's just extra information. All right, so we've got that out of the way. The flow into the tank from the treatment plant is 750,000 gallons per day, and we have a flow out of the tank at 850 gallons per minute. So notice we've got different units here, actually three separate units showing. We've got gallons per day, we've got gallons per minute, and we've got million gallons. So there's a lot of different units being thrown around here, and we want our answer to be in hours. So actually that's 4 different units that we're working with. So let's go ahead and just dissect this piece by piece. So let's kind of do something like this. I want to draw a little circular tank here. This is going to be a cylindrical tank, just to kind of keep everything straight in our mind. And in this cylindrical tank, we know right now we've got 3.2 million gallons, and we're flowing into the tank at 750,000 gallons per day. So I'll put that here. And we're flowing out of the tank into the water distribution system at 850 gallons per minute. I like to draw pictures because it kind of helps me keep everything straight. So we've got 3 different units showing here, and what we're going to do is, in the method I'm going to show you, I think will help kind of simplify this a little bit. Let's figure out first what the actual flow out of the tank is, because it says 850 gallons per minute, but we've got flow in at 750,000 gallons per day. So we're filling and pulling out at the same time. Let's figure out really how many gallons per minute are actually being pulled out of the tank, based on the information we've got. So first thing I want to do is take the 750,000 gallons per day, and I want to convert that into gallons per minute. So we're going to go like this. We're going to take 750,000 gallons per day, and we're going to divide that into gallons per minute, or to make it gallons per minute, we're going to divide it by how many minutes are in one day, which is 1,440 minutes per day. All right, so let's work that out. So 750,000 gallons per minute, divide that by 1440. So I'm coming up with 520.83 gallons per minute. All right, so that's what's filling the tank, and we're coming out of the tank at 850 gallons per minute. Let's now figure out the difference and really what the flow out of the tank is true. So we've got 850 gallons per minute out. Let's subtract from that 520.83 gallons per minute in. And let's now figure out what the number is, the difference. So 850 minus 850 minus, subtract from that 520.83. And I get a true flow out of the tank. The difference here is 329.17 gallons per minute out of the tank. All right, so far so good. Now what we need to do is figure out the tank capacity and then figure out how many gallons per minute, or rather how many minutes it'll take to empty that 3.2 million gallons based on the flow out of the tank. So we're going to remember this number. We need that for later. And what I'm going to do is erase a little bit of this on the screen so we have a little bit more room to work here. So I'm going to erase this. I'll just bear with me just for a second. We've got all that kind of figured out. We've got this figured out. Let's erase some of this, get this out of the way here. And we know that. And then we know this part. So let's go ahead and erase this part here. So we've got all that figured out. Now let's go back to the math here. So we need this million gallon units to be in gallons, not 3.2 million gallons. We want this to be in gallon units. So 3.2, multiply that by the number 1 million to put this into mg, or million gallon, or I'm sorry, gallons units, is 3,200,000 gallons in the tank. So we're pulling out of the tank at 329.17 gallons per minute. And now what we're going to come up with is minutes that it's going to take to empty the tank. So let's go ahead and erase this and get this out the way because we're done there. And let's work this math. So 3,200,000, divide that by 329.17. And I came up with 9,721.42. And this is minutes. So gallons cross out again, we're left with minutes. So we've got 9,721.42 minutes. Now what we need is to figure this into hours, because the question is asking us hours. So we're going to divide this by 60 minutes per hour. And we're going to be left with hour units. So 9,721.42. Divide that by 60. And I came up with 162.02 hours. All right, that's a lot of hours right now. So 162 hours, that's more than a day, that's more than several days. So the question right now is answered. We've answered the question, how many hours? But what if this was to say, instead of hours, what if this said, hey, how many days would it be? What if it was days? Well, we've got one more step to do then. I'm going to work up here on the screen. I'm going to move this up a little bit. So we've got 162.02 hours. And we know that there's 24 hours per day. So now let's go ahead and just divide this 162.02 hours divided by 24. And I came up with 6.75 days. There we go. So if you want the answer in days, 6.75. If you want the answer in hours, 162.02. We've got a little bit more than one whole week, or just short of a week rather, sorry. Just short of a whole week of days of time before that tank would be empty. That's how you work that one out. So again, we didn't use any formulas from the formula sheet. We essentially just used some conversions and kind of did a concept math. If it helps you to draw them out, draw the units out, you know, like I did here with little pictures, I think that helps some people too, because we're maybe a little bit more visual learners. All right, so here we go. We've got one more to do. Let's work out something that's probably the more, you know, complicated part of this. And this will take us a few seconds more to do here. So we've got a ground storage tank. It's 25 feet tall, 87 foot in diameter. The tank is 80% full. The flow into the tank from the treatment plant is 650,000 gallons per day. And the high service pumps discharge 900 gallons per minute into the distribution system. How many hours will pass before the storage tank is empty? All right, so we've got a similar question, but now we have to figure out the gallons in the tank. We don't know the gallons in the tank, so we've got some extra work to do. So the first thing we're going to do is figure out the gallons in the storage tank. So we're going to draw out a little picture here because, again, like I said, I kind of like to see a visual image. And please forgive my artistic abilities, but it's obviously not to scale. Hopefully that's not what your tanks look like. We've got a tank that's 25 feet tall, right? So there's 25 feet, and it's 87 foot in diameter. So we're going to put 87 foot here, right? So that's coming across there. So that's 87 foot in diameter. And now we need to know how many gallons are in the tank. So remember the formulas that we did earlier. I'm going to use 0.785 times 87 times 87 times 25. And we're trying to get gallons in the tank. So if you are working the math and you came up with 148,541.625, if you got that on your calculator, that's actually cubic feet. That's not the gallons, that's cubic feet. So don't forget, we got to convert this into gallons. If you stop right at this point and don't do the 7.48, you're going to get a wrong answer. So let's go ahead and multiply this by 7.48. And I came up with a tank that holds 1,111,091 and 0.355. So I think I'm just going to go ahead and drop off the 0.355 from this, and we'll just go with that number that you see here. So we're going to put here million gallons. I'm sorry, that's not million gallons, that's just gallons. So I apologize, that's just gallons. Million gallons will be 1.111, but we're just going to put gallons here. All right, so are we finished? No, we're not finished yet, because don't forget, the tank is only 80% full. So what we need to do now is figure out the true amount of water in the tank. So you got your number of 1,111,091 times, now we're going to multiply this by 80%, so 0.8 times 0.8 is going to give me a true tank volume, or gallons rather, of 888,872.8 gallons. All right, there we go. So let's erase some of this stuff out of the way here, because now we're getting kind of messy. Got a lot of numbers showing up here we don't need in our way. Let's remove all that stuff. And now we've got our true gallons in the tank. So there's our tank top again, back on there. All right, so we've got that part done. The flow into the tank from the treatment plant is 650,000 gallons per day. And we're flowing out of the tank at 900 GPM. So let's go ahead and convert the 650,000 gallons per day into gallons per minute. So 650,000 gallons per day, divide that by 1440, and I'm coming up with a flow into the tank at 451.3. We're going to round this and say 0.39 gallons per minute. There's our flow into the tank. Let's erase this 650 and get that out of the way. And let's go back to our math. Now we got to figure out the true withdrawal rate from the tank. So the true withdrawal rate is going to be 900 gallons per minute out minus 451.39 gallons per minute in is going to equal, let's see, we got 900, subtract 451.39, and I've got a true flow out of the tank of 448.61 gallons per minute. That's really what's flowing out of the tank. Let me go back and erase this and get this out of the way. So there's our true flow out. Let's erase that. And let's erase that because we're done with those numbers, and back to our pen. So now we've got the tank volume, or the tank contents right now is 888,872.8 gal. Divide that by our flow out of the tank of 448.61 GPM. And we're going to end up in minutes. You kind of see that we're going to end up with minute units here because gallons are going to cancel out. So let's work this out. 888,872.8 gallons in the tank. Divide that by 448.61 gallons per minute. And I'm coming up with 1,981.39 minutes. All right, so there's our minutes of time, and the question was saying hours. We don't want minutes, we want hours. So let's divide this by 60 min per hour, and let's see what we get. So 1,981.39 is the minutes. I'm sorry, yeah, minutes divided by 60, and we came up with 33.02, but we don't really need to worry about that. It's the small numbers here, but we'll put it up here. 33.02 hours before that tank is empty. So that was a lot of steps. And I like to joke to everybody, you know, in my classes, I say things like, you know, man, it's a lot of time that took to do that question. How many points is that question worth, right? It's still only worth 1 point on the exam, but don't take that lightly, because that could be the 1 point that you actually need to go from a 69% to a 70%, and that could be the passing grade that you need, the passing question that you need. So, you know, don't take it lightly. You can do this math, practice this, watch this video, repeat it if you need to, kind of go back and watch it again. Hopefully that'll help you guys out with working this math out. All right, so that concludes the session. Thanks for watching. Again, contact me if I can be helpful. And if you have any questions, let me know. I'll be glad to help you out with that. Or if you want to comment, just let me know. And I hope this is helpful. Good luck, everybody. Thank you.